Hello everyone, in this video we will discuss dynamics. The first concept of the video is Newton's laws of motion. There are three laws of motion starting from first. Object will continue its state. State can be two, it can be of rest or uniform velocity. And if there is no resultant force, the object will continue its state, which means it will either be at rest or it will move with a constant speed in a straight direction. So this is Newton's first law of motion. If there is no resultant force, there will be no change in state. So object will either be at rest or it will be moving with constant velocity. The second law is if there is a resultant force on the object, then the object will accelerate, which means the object will change its velocity, or you can say the object will not continue its state. If it was at rest, then it will start moving. If it was moving, it will either speed up or slow down or will change its direction. So if there is a resultant force, there will be change in acceleration. Resultant force and acceleration are always in the same direction. This is Newton's second law of motion. Now the third law is if object A applies force on object B, then object B will also apply force on object A. The magnitude of the force will be same, but the direction will be opposite, which means FA is equal to minus FB, which means the force of A on B is equal in magnitude but opposite in direction to the force of B on A. Newton's third law pair of forces have following properties. They act on different objects, which means that objects on which the forces are applied are different. There must be two objects on which the force acting will be equal and opposite, equal in magnitude, opposite in direction, and the type of force must be same, which means for example, if there is a book and the weight of the book is 20 Newton, so the normal reaction force is also 20 Newton. The magnitude is same but the direction is opposite. This force, which is actually equal in magnitude but opposite in direction, is not the Newton third law pair. Why? Because weight is actually the force which is applied by earth on the book, and the normal reaction force is actually the force applied by the table on the book. So there are in this case two types of forces, weight and normal reaction, and you can also see that there are more than two objects. One is book, second is table, and the third one is earth. So these two forces are not Newton's third law force pair. Now the second main concept is mass. Mass is actually amount of substance in the object, but the advanced definition for mass will give you a broader perspective. Mass is actually the property of a body that resists change in motion, which means if object is more massive, it will resist more to the change in state. If it is at rest and you apply force, the object will resist. If the object is massive, you will need to apply more force on the object to change its state. So mass is the measurement of inertia of the object. Inertia is actually the property of mass that resists the change in state. If object is more massive, its inertia will be more, which means if there are like two objects, for example, if there are two chairs, one chair is empty and the other chair is actually on which the person is sitting. So the empty chair is easy to move because it will have less mass, so less inertia. Similarly, if there is a chair on which a person is sitting, you cannot move it easily, which means you will need to apply more force in order to change its state. So it will have more inertia. Now weight is actually the effect of gravitational field on the mass, or you can also call it gravitational force acting on the mass as weight of the object. Weight is actually given by mass multiplied by acceleration of free fall, and acceleration of free fall for earth is 9.81, and in case of moon it is 1.6 Newton per kg. Now momentum is actually product of mass and velocity. If an object is at rest, its momentum will be 0. So mathematically you can write P is equal to m times v, where P is small p, momentum, m is mass, v is velocity. SI unit is Newton second, and Newton second is actually equivalent to kg ms minus 1, which is SI base unit of momentum. Momentum is a vector quantity, which means if an object is moving right and you take its momentum positive, then the object which is moving towards left, you will take its momentum negative. So it is a vector quantity, direction dependent. Change in momentum is equal to mass multiplied by change in velocity. Now we are studying Newton's law of motion in terms of momentum. So first law, which actually stated that if there is no resultant force, there will be no change in state. So if there is no change in state, which means there is no change in velocity, and in other words we can say that there is no change in momentum. So if there is no resultant force, an object continues its state, which means there is no change in velocity. Can I call it that if there is no resultant force, there will be no change in momentum? No resultant force, no change in momentum. If F is 0, which means resultant force is 0, then change in momentum, which is delta P, is also equal to 0. It means if an object is at rest, its momentum is 0 and will be 0 if there is no resultant force. Similarly, if an object of mass 700 kilogram moving with velocity of 10 meters per second towards right, then its momentum is 7000 kilogram meters per second, or 7000 Newton second. Its momentum will be 7000 Newton second unless you apply an extra or unbalanced force to change its momentum. So whatever the momentum of the system is, it will be constant if there is no resultant force. Similarly, if there is a resultant force acting on the object will accelerate, right? Acceleration means change in velocity, or you can say if there is acceleration, there will be change in momentum as well, because change in velocity causes change in momentum. So according to Newton's second law of motion, we can also rephrase it. If there is a resultant force, then there will be change in momentum. If resultant force is not 0, then change in momentum will also be a non-zero value, which means if there is more resultant force, there will be more rate of change of momentum, more change in momentum per unit time. When proportionality constant is removed, when proportionality value is actually removed, we put a constant here, but actually the value of constant is 1. That's why we have written F is equal to delta P upon delta T, where delta P is actually m delta V and delta T is as it is. Delta V upon delta T is actually acceleration. Change in velocity per unit time is acceleration. So F is equal to delta P upon delta T is actually equivalent to ma. So we can define force by Newton's second law of motion as rate of change of momentum. So this is the definition of force, and if the examiner asks about statement of Newton's second law of motion, you will write resultant force is directly proportional to rate of change of momentum. Now in third law, which states that if object A applies force on object B, and object B applies the same force of magnitude and opposite in that direction of the force A, we can rewrite or rephrase this in terms of momentum as Fa is equal to delta Pa upon delta T. Similarly, Fb is equal to delta Pb upon delta T. Since time of collision is same between the two objects, so delta Pa is actually equal to minus delta Pb, which means change in momentum of object A is equal but opposite to change in momentum of object B. Now if I put minus delta Pb to the left hand side, the equation will become delta Pa plus delta Pb is equal to 0, which means the total change in momentum of the system is 0. System means more than one object. If you say system, it means there are more than one objects which we are talking about. Now law of conservation of momentum states that for a closed system, the total momentum of the system before collision is equal to total momentum of the system after collision, which means the total momentum of the system remain conserved or constant. Closed system means isolated system. Isolated system means a system that is not acted upon by external force. For example, if there are two objects interacting or colliding with each other, we are not taking into effect the effect of air resistance, gravitational force, or any other force other than the force which was actually existing when the two objects were colliding. That was Newton's third law pair. Now, the explanation of law of conservation of momentum, you have to consider two objects A and B of masses m1 and m2 moving towards each other with velocities u1 and u2 as shown. The momentum of object A is m1 u1, the momentum of object B is minus m2 u2 because the direction is opposite to A. So the total momentum will be m1 u1 plus minus m2 u2 because the object B is moving towards left. After collision, let's say the object A moves towards left and object B moves towards right, object A with velocity v1 and object B with velocity v2. Then the momentum of object A will be minus m1 v1 because it is now moving left, and m2 v2 positive of object B. So the total momentum after collision is minus m1 v1 plus m2 v2, and the law says m1 u1 minus m2 u2, which is actually total momentum before collision, is equal to minus m1 v1 plus m2 v2, which is the total momentum after collision. This is actually a special case, but the general equation for the law of conservation of momentum will be m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this is the main equation which you have to use if the examiner says that the two objects are of same mass. So you will not write 1 and 2 with masses. So you will write mu1 plus mu2 is equal to mv1 plus mv2. Similarly, if the examiner says the objects stick together after collision, so right hand side part will become m1v plus m2v if the two objects are different but they stick together, so it will become m1v plus m2v. And similarly, if the two objects are of equal masses and they stick together, so it will become mv plus mv. We will discuss this when we will be solving question in the next video. Now in this case, as you can see, there are two objects and the two objects are of equal masses. So the momentum of object A before collision is 60 m, the momentum of object B is 30 m, but in the opposite direction, that's why we will write negative with it. After collision, they stick together, so it will become m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. 60 m minus 30 m is equal to 2 mv because the two objects stick together and the objects are of same mass. So mv plus mv becomes 2 mv. 30 m is equal to 2 mv, m cancels m, so v is equal to 15 centimeters per second. This is the answer. Now in this question, the momentum of object A is 16, the momentum of object B is 8, and after collision they stick together, so it will become 16 plus 8 is equal to 6v, and 16 plus 8 is 24, 24 is equal to 6v, so it will become 4 meters per second. 24 is equal to 6v, v is equal to 24 upon 6, so 4 meters per second is the answer. This question is also done briefly in the next video as well, so I have done directly here. If you need more explanation, go to the next video. Now in this case, this is an important case. There are two objects, object A and object B. This is before collision. After collision, object A and object B moves with angle alpha and beta with velocities v1 and v2. Before collision, object B is at rest while object A is actually moving and it strikes object B. In this case, before collision, the object A and object B, object A was moving horizontally and object B was at rest, but after collision, object A and object B both moves, and the object A and object B are not moving horizontally or vertically, they are moving in projectile, which means motion in 2 dimensions, because object A is covering horizontal as well as vertical distance. So in this case, we will make two equations, one for horizontal and one for vertical. Now if I talk about horizontal motion, horizontal, so for horizontal case you can see that the momentum of object A is m1 u1 while the momentum of object B is 0. After collision, the object A moves with velocity v1, but this velocity v1 is not just horizontal velocity, it is actually resultant velocity. So you have to simplify v1 into its rectangular components, and you will do this by making a vector triangle. As you can see, v1 is the resultant velocity, so you will resolve v1 into its components v1x and v1y, and according to trigonometry, v1x is actually v1 cos alpha and v1y is v1 sin alpha. So object A is actually moving horizontally with velocity v1 cos alpha. Similarly, object B is moving with velocity v2 cos beta horizontally. So after collision, the momentum of object A will be m1 v1 cos alpha. Similarly, momentum of object B will be m2 v2 cos beta. We have added the two because the two objects are moving in the same direction. That's why the momentums will be added. Now if I talk about vertical momentum, this object A is not moving vertically before collision, so its momentum will be 0. This object B is not moving vertically before collision, that's why its momentum is also 0. After collision, object A moves upwards, as you can see, with velocity v1 sin alpha, and object B moves downwards with velocity v2 sin beta. So the momentum of object A after collision vertical will be m1 v1 sin alpha, and for object B it will be m2 v2 sin beta, and negative sign is actually because the objects are moving in opposite direction. So this is what you will do when there is a case of projectile momentum. Now types of collisions, there are two types of collisions. One is elastic and the other one is inelastic. Elastic collision is one in which the momentum is conserved, the kinetic energy is conserved, and the relative speed of approach is equal to relative speed of separation. Let's talk about kinetic energy first. If there are two objects and they collide, whatever the total energy the system had before collision, it will be equal to total energy of the system after collision. As you can see, before collision the kinetic energy of this object is m1 half m1 u1 square. Similarly, of object B will be half m2 u2 square, and after collision the kinetic energy of object A is half m1 v1 square, and kinetic energy of object B is half m2 v2 square. So according to the situation of elastic collision, we will say half m1 u1 square plus half m2 u2 square, which is actually kinetic energy before collision of the system, is equal to half m1 v1 square plus half m2 v2 square, which is kinetic energy of the system after collision. So this is for elastic collision. Now if the collision is elastic, the relative speed of approach is also equal to relative speed of separation. Now for the concept of relative speed of approach and relative speed of separation, let me give you an example. Let's say there are two objects A and B. Object A is moving towards right with speed 10 meters per second. Object B is moving towards left with speed 5 meters per second, and the distance between the two objects at time 0 is 30 meters, right? So after 1 second, the object A will move 10 meters towards right, and object B will move in this 1 second 5 meters towards left. So that separation between the two objects will reduce to 15 meters. It was 30 meters earlier, now it is 15 meters. After 2 seconds, the object A will cover 20 meters and object B will cover 10 meters, so that the separation between the two objects will be 0, which means in 2 seconds the two objects cover 30 meters. So relatively 30 meters divided by 2 seconds gives 15 meters per second, and this speed is not of object A or object B, it is actually relative velocity of the two objects, which is 15 meters per second. Similarly, if after collision object A moves towards left with the speed 8 meters per second and object B moves towards right with speed 7 meters per second, so after every second the separation between the two objects will be 15 meters per second, which means after 1 second the object A will move towards left with 8 meters and object B moves towards right 7 meters. So as a whole, after 1 second they will be 15 meters apart. Similarly, after 2 seconds it would have covered for 16 meters, and similarly it would have covered 14 meters, and in 2 seconds you can see that the two objects are 30 meters further from each other, and this is actually 15 meters per second relative speed of separation. So relative speed of approach is actually, if I say it, if it was 10 meters per second and it is 5 meters per second, so you can simply find out relative speed of approach by adding the two speeds. And similarly you can find out the relative speed of separation by adding the two speeds of object A and B. But if, for example, okay, so if the collision is elastic, u1 plus u2 is actually equal to v1 plus v2, which is actually 10 plus 5 is equal to 8 plus 7. Now in the next case, so what actually we have to do is, when the direction are opposite, we actually add them. u1 and u2, they are moving in opposite directions, so their speeds are added to find out the relative speed of approach. Similarly, v1 and v2 are actually velocities in opposite directions, so we have added them to find out relative speed of separation. Now I am giving you another example. Object A and object B. Object A and object B are moving towards the same direction. Let's say the speed of object B is 10 meters per second. The speed of object A is 6 meters per second. So in 1 second, object A will cover 10 meters, object B will cover 6 meters. So after 1 second they will be 4 meters apart, and similarly after 2 seconds they will be 8 meters apart. So actually their relative speed of approach is 4 meters per second. Similarly, v1 and v2 is actually the two objects moving away. Let's say object B has a speed 2 meters per second towards right, and object A has speed 2 meters per second towards left. So the relative speed of separation of the two objects will also be 4 meters per second. If the two speeds are same, you will call it elastic collision, because whatever is the speed of approach is actually the speed of separation. In this case, u1 should be greater than u2, which means u1 should be 10 meters per second and u2 should be 4 meters per second, 6 meters per second, so that the objects collide, and the relative speed of approach is 4 meters per second. We can give more examples when we are solving questions. Now part B, inelastic collision. Momentum is conserved, kinetic energy not conserved, relative speed of approach is not equal to relative speed of separation. So if the collision is inelastic, its momentum is still conserved, the kinetic energy is not conserved, the relative speed of approach will not be equal to relative speed of separation. This is actually what you need to understand when you are solving questions related to dynamics. So in the next video I will be helping out in solving questions which are related to dynamics. So be connected, please. Subscribe to the channel. Thanks for watching.